Hello guys, welcome to day 8 of 21 days of code series with Ozone. Today, here I am with first problem for the day, that is number of matching subsequences. The problem states that given string S and a dictionary of words, find the number of words that is a subsequence of S. Now, we'll try to understand the problem first and then we'll jump towards the example. The problem is trying to ask us to find all such strings in the dictionary words which are a subsequence of the given string S. Now we will try to analyze the example so that we understand what the problem is actually trying to ask us. So here the input string is A, B, C, D, E and the words dictionary contain the words A, B, B, A, C, D and A, C, E. So for this case, A is a subsequence of S as A can be directly found in the string S. BB is not a subsequence of S because we have only one B in the input string. Similarly for ACD, now we have A here, C here and D here in the fashion that we want. So it is also subsequence. In the case of ACE, A is there, C is there and E is also there and the order is also same. So we will consider this input also. So for this example, we will return 3 as answer because there are 3 words in the given dictionary that are a direct subsequence of S. Now, how do we approach the solution of this problem? How do we actually find out that whether a given string is a subsequence of the master string or not? That we can check the index of each character and limit our search into a particular space. Now that might sound a bit tricky at first. We will be iterating over this words dictionary and for each character we will find its index in S. For the strings that have only one character, we will simply be able to return the index. So for the strings that have more than one character, if we try on computing the index of each character over the complete string, that would be a complete mess and the asymptotic time complexity will be bigger of n square. As in this case, if you try to find the index of first B, it will return 1. But if you try to find the index of the second B, it will again return 1 because you are starting from the initial. But that's not good because we can use the characters only once. So there is an inbuilt function in Java that is index of, that can take string as a parameter and an starting index from which you want to find the index of a particular character. It would be more clear with the example ACD. We'll have an initial value of index variable assigned to -1 and then for the example ACD, we'll be iterating it character by character. So first we'll be encountering A. So this will yield us to update the value of our index to 0. And then if we move on to C, the search will begin from index number 1. And it will finally return the value of I to us be equal to 2. Further moving on, if we try to search D, the starting index will become 3 and it will return the value of index equal to 3. Now this was the case for a successful search, but in case of a string that does not exist as a subsequence of the given string, the return value of index of function will be -1 and for each character we will keep a check whether our index is becoming -1 or not, and in the case our index becomes -1, we will simply break out of the loop and consider not to add that particular string in our result. Things would get more clear when we move towards the code part. So now let's switch towards the code. Here is our LeetCode ID. Now we need a variable to keep account of the strings that are a valid subsequence. So we'll initialize the count variable and then further moving on, we'll iterate over this words dictionary and for that I am using an enhanced for loop here. Now again, As we have already talked, we will have a boolean to consider whether the value is to be added or not. Now we'll be initializing our index with -1 and then start iterating over the particular word character by character. The index will be equal to s.index of ch, index plus 1. That is the same thing that we talked about here, 0, 1, 3. Alright. And if at a particular case, if index becomes -1, we will make our toArt false and break out of the loop. Towards the end, we will be checking whether our toArt boolean is true or not, and if it is true, we will increment our count. And at the end of the function, we will simply return count. Now we will run it. Cool, so it seems to work over this example test case. Now let's try to submit the code to this problem. Perfect. Now this process actually took a lot of time because we might encounter the situation where the same word is being searched for again and again. So we'll be using a hash chart to maintain all those words that are a valid subsequence, and if we encounter the same word again, we can simply increment our count and break the loop. Initializing our hash set and checking if it contains our word, we'll increment our count and continue. And in the case the word doesn't exist in the set and is a valid subsequence, then we'll add it after. Now we'll submit this code again. Beautiful. You can see that the time has reduced to almost 1/5 of the time that we were using earlier, with just a minor increment in the memory that we were using. So that's a major improvement by using the set and keeping a track of all the words that have already been used. Thank you for watching.